Okay, let us go with powers. Now, guys, you can read that first line there just as well as I can. I'm not going to read it out loud to you, but I am going to highlight these two words, repeated multiplication. At one point over the course of this unit, one of you at least is going to tell me that 7 to the third power is 21. One of you is going to say that, which will hurt my feelings a little bit because, of course, 7 times 3 is not repeated multiplication. That is repeated addition. 7 plus 7 plus 7 is 7 3 times to get 21. My favorite thing is when people talk when I'm trying to teach something to them and then 2 seconds later ask me for help on what I just tried to teach them. That's my favorite thing. So by all means, keep that up. Okay, just making sure you're aware of how much that's my favorite thing. Okay. So I want to be absolutely sure that you understand that 7 to the third power means 7 times 7 times 7. I don't care what the value is. That's not what this is about. All of you are like, oh my God, I gotta know. No, you don't. In the 9th grade, you had to know what that was. In the 10th grade, I don't care what the value is because we do not care about the values. We care about the process. If you understand this, then every other thing I'm going to show you today, tomorrow, and for the next few weeks already makes sense. If you understand this relationship, then no matter what I do with exponents, if you write it out that way, you will always be able to get 100% on every exponent question. If you choose to understand that concept. If you choose to memorize 10 steps, you are going to get questions wrong. Does everybody understand what I mean by the difference? Okay, let's carry on a little bit. First thing I'm going to do is highlight the word base. Then I'm going to highlight the base in this giant expression that I have here. But I'm going to highlight the base, but only when one of you tells me what to highlight. 7. Excellent, yay. Now I'm going to ask you a question that has 2 answers. One of them is concept-based. One of them is visually based. The question is this. What is a base? Okay, we've gone back 2 units, but yes, okay. No, that's fine. Because we call this the base for a reason, because it is the foundation of the whole power. I agree with you, Tasha. Excellent. Slightly more germane to this situation. Nick? Yes, excellent. The base is, and I don't want to use the word number because in the 9th grade it was always a number, but it does not have to be. The term that is repeatedly multiplied. That's what a base is. Now, in red, I want to write where I find a base, because that's the other side, right? The big number. That's what everyone says. It's the big number. If it's going to be a number, but I just told you in the 10th grade it's not always a number. The big term. And I'm going to add one little bit to this that is on. No, I don't want to write on. I just got to wait a second till I can erase. Still can't erase. That is directly, and please underline the word directly, left of what? of the exponent, which I am now highlighting in blue and going up there. Now, concept-wise, what is the exponent? Concept-wise. Yes, the number of multiplications. All right? Everybody cool? You all know that from the 9th grade, yes? So now I'm going to do something that you might not know from the 9th grade. Or you may have forgotten. And I'm going to write it in red because it applies to this situation over here. Okay? Remember, a base is the term directly to the left of an exponent. So, 3 squared. What's the base? 3. Lovely. Negative. So the base there, base equals 3. Negative 3 squared. What's the base? 3. Why? James.
Because there's no brackets around the negative 3.
Because the thing that is directly left of the exponent is only a 3. And finally, negative 3 squared. Now what's the base? That base is negative 3.
So if you were to write out the second one, it would just be 3 times 3 times 3.
We're going to get to that.
Okay.
Base equals negative 3. Everybody good? So that was grade 9, yes?
Yes.
But notice I've changed the wording to the term. So what is the base here? Excellent. What is the base here?
X plus 7.
It's 7. Why, Sam? Because that's the only thing to the left of an exponent. What is this base here? X plus 7. Is everybody good? That's the first tiny bit of new thing. What? Oh, didn't even recognize it. Thanks, buddy. Everybody good? All right. The power is the whole thing. Base and exponent. And it's read as whatever the base is, which I'm highlighting in yellow, to the come on! To the exponent, which I'm highlighting in blue, power. So this is 7 to the third. 7 to the third gets a special name. 2 kinds of exponents get special names. What are they? Cubed and squared. Seven squared. 7 3 is cubed. Now, I'm going to shut up for a small bit of time while you and possibly your neighbor work to fill in this chart. I'm going to do the first one with you to show you what I want it to look like. Power, right there. What's the base? 2. What's the exponent? 4. What's that mean? 2 times 2 times 2 times 2. What does evaluate mean? It means the value of the power with no exponent. Some of them you're going to be able to do in your head. Some of them you're going to need your calculator. Some of you may forget how to do that on your calculator. That's okay. I'm going to remind you. If you have to leave one of these blank, go ahead. 16. Sam, that's the point. I want to see what you guys remember. I am going to shut up while you guys try to fill this in. You're allowed to talk to each other. That's the whole point. Talk to your neighbor. Let's go over a few of these. Moving on to the second row. What is the base here? 3. What is the exponent? 3. If the base is 3 and the exponent is 3, how many 3's do I have to write in here? 3. Which is 27. But what does that negative do? Means there's a negative in front of everything we do, so there better be a negative in front of my answer. What, Riley? The negative is outside of the bracket. 3 times 3 times 3. The base of 3 has been repeated thrice, but then it's out in front. Cool? Okay. This is a problem because kids who don't pay attention do not understand what I'm about to show you. Do not write this down. Negative 3 cubed, we just did, is negative 27, yes? What is negative 3 cubed? TJ? Still negative 27. How can 2 different things give you the same answer? What's the base here? What's the base in the bottom one? No. Negative 3. So this bottom one is negative 3, negative 3, negative 3. 2 negatives make, say, times another negative. That's why you stay at negative 27. Okay? Please notice they are 2 different things. One of them is 3 times 3 times 3 times negative 1. And the other one is negative 3 times negative 3 times negative 3. That is a big problem with my grade 10 students who do not pay attention. What's the base in the third one? Negative 5. What's the exponent? Which means how many negative 5's do I need? 2 of them. Making the answer positive 25. Because when a negative multiplies by a negative, I get a positive. Gouda? Base 8. Exponent 5. How many 8's? Now, next thing that you might need to remember how to make your calculator do this. If you have forgotten, you are looking on your calculator for one of the 4 following keys. X with a little y, y with a little x, x with a blank. Oh, I guess it could be 5 keys because it might be y with a blank or it might be this little mountain symbol that is called a caret. I don't know why it is called a caret. It just is. And you do these whether you have a forward or a backwards calculator the same way. It is base, then whatever your key is, I just put a K for key for whatever one you have, then exponent, then equals. So somebody should be able to tell me that value, and they should be able to tell me that value as a number, not 5 digits. Yes. 32,768. Okay? Okay. So this is different now. I've got what as a base? How many times? 5. What's the value? And what's the power? Excellent. What's my base here? What's my power? 7. What's my, exponent was 7. What's my power? Wrong. -1 bracketed. To what power? 7. Do you understand the difference? Is that what you meant? Okay, I believe you. What is the value? What? -1. 10 cubed is what? 10 times 10 times 10. What's the value? 1,000. What's the power? 10 cubed. X cubed, what's the base? What's the power? What's the repeated multiplication? X, X, X. Naughty. What's the evaluation? No. X cubed. You have to leave that like that, don't you? Why? Why? Because the X is variable. You don't know what it is, so you cannot give it a value. Now, this next one is the first tricky one. Why is it tricky? Doesn't show a negative in either the base or the exponent. So what has to write here? Excellent. So 2 times 2 times 2 times 2 times 2 is 32. How do I make that negative? Brackets with a negative out in front. That would work. So what would the power be? -2 to the 5th. Is there another way I can write that? You can't change the base. It's already written there. Is there another way I can write that? But what if I did this, Aiden? What if I took away that base? Now, is there another way you could write it? What could you make the base? -2 written how? In brackets in the power. Because then the negative would repeat. And since the negative was repeated an odd number of times, I would still get -32. Nice. Now, this is also, the next two are kind of tricky. The value's 9. What can I use to make 9? I could use 3 times 3, which would mean my base would be 3, my power would be 2, and my exponent would be 2, my power would be 3 squared, yes? Is there another way? I could do -3 times what? I should do that in red so it's a different color. I could do -3 times -3, which would mean my base would be what? -3. My power, my exponent would be? And my power would be? Bracketed -3 squared. Huh? Okay. Now, because I'm mean, I have another 9 here. How else could you do it? 1 9. So what's the base? How many times did it repeat? What's the power? Oh, I didn't fool any of you. 9! Why? Because we never write 1 as an exponent. Whew. Nice. All right. Tricky McTrickleton. What's the base? -4. What's the power? Write it out. Okay, Jack?
Okay, so it would be negative, then brackets, then -4 times -4 times -4 times -4 times 6 times. 6 times.
And what's the answer?
-4,096.
-4,096. Now, somebody should be saying, but Mr. Myers, you said if it was an odd exponent, it would be negative. This is an even exponent. But there's another negative out in front. It is a trick. But I didn't fool any of you.
Yes, you did. You fooled me.
Did I fool you the first time?
You did.
I did?
You did.
Oh, way to be honest, buddy.
Well,
Nice.
don't put 6 in the beginning.
What's the base? What's the exponent? How do I write it? What's the value? Excellent. Now, before we go on, I want to make sure that you are aware of something. You've already written it on here a couple of times. You may need to write it down again, or you may actually remember it. Please, please, please. Negative 5 squared is what? Negative 25. Negative 5 squared is what? 25. Negative 5 cubed is what? Negative 125. Negative 5 cubed is what? Negative 125. Okay. Negative 5 to the fourth is what? Negative 625. Negative 5 to the fourth is what? Positive 625. Is everybody good with that subtle distinction? The negative is only part of the base if it is in brackets. Aight? Aight. It's a 4. It's a 4. Why would I go 2, 3, 4, 2, 3, 9? It's okay, Tash. I'm just giving you a hard time. Relax. All right, turn over to page 79. The first 4 things here you already know from the 9th grade. But if you were not in my class, you might only have done them in one way. I am going to expand that one way with you right now. If you were in my class in grade 9, you've already seen what I'm about to do. Multiplying powers of the same base. So in the 9th grade, you were given this. 2 squared times 2 cubed, and asked to multiply it. Hopefully your teacher showed you why this works. He or she did not give you the shortcut first. Why does this work? What is this really? 2 times 2. What is this really? 2 times 2 times 2. Notice there's a times between there, so what goes here? Times. How many 2's do I have? 2 to the 5th. What is the connection between 2, 3, and 5? Right. 2 plus 3 equals 5. Now, you guys are smart kids. If something happens once in math, how often does it happen? Always. So, if you are multiplying powers of the same base, what do you do with the exponents? Add them. So now, let's change this slightly to include everything, not just numbers. The rule is x to the a times x to the b, same base, is x to the a plus b. Everybody cool? All right, now don't write down what I'm about to write down. I want you to think about it. What would be the answer to the question that I'm going to write when my computer thaws? 3x plus 2 times 3x. Sam. 3. What do I do with the exponents? Add them. How many x's are up there? 2x plus 2. The rule doesn't change even though the looks change. Does everybody understand? Good? Okay. You won't see variables in an exponent like that till grade 12, but I want you to be aware that it doesn't matter what happens, the rules don't change. The other mistake that kids make is if I give them this for a question, 2 squared times 2 cubed, they try to tell me the answer is 4 to the 5th because they want to do 2 times 2. Does that make any sense? No, that is completely wrong. Do not do it. Okay? Everyone's good with multiplying, yes? All right, dividing gets a little bit tricky. Last year you saw it written this way. 2 to the 4th divided by 2 squared. That's how you saw it written last year when you were first introduced to this. What's another way to write that same thing? 2 to the 4th over 2 squared. Same thing, yes? Now again, what does that actually mean? What is 2 to the 4th?
4 minus 2.
2? No, that's what you do. What does it mean? What do you do with the 2's? Cancel, cancel. What's left? 2 squared. The relationship is 4 minus 2 equals 2. How do I put that into general terms? This is a specific case. How do I write it over here? X to the, what letters am I using? A divided by x to the b equals what? A minus b. Everybody good? Easy peasy lemon squeezy, right? You already knew that with numbers. Now you're learning it with letters. Everybody okay? Yeah. All right. Raising an exponent to an exponent. 2 squared to the 3rd. What does that actually mean? Aiden.
2 times 3.
Again, you're telling me what to do. What does it mean? Pardon?
It means you multiply 2 by the exponent of 2 and then you multiply by.
Okay, I'll change the question. What's the base here? 2 is one of the bases here. 2 to the power of 2 is the base, isn't it? So it is 2 to the power of 2, yes? How many times? Thrice. Agreed? What is 2 to the power of 2 really? 2 times 2, 2 times 2, 2 times 2, to get 2 to the 6th. Now, Aiden, what did I do? I multiplied the exponents, right? The 2 times 3 was 6. Now, how do I write that in nice general terms? X to the A, all to the B is X to the A times B. Everybody cool to there? Okay, now here's where it starts to get snaky. If this exponent law applies, do the first two still apply? Yes or no? Yes, because they are laws. Every time you do something with an exponent, every law applies. Understand? So we're going to do something with number 4, which might be new to some of you. 2 over 3 squared. What's that really? What's the base? 2 over 3. And how many of them do I need? 2. Right? Is there a shorter way to write that? 2 squared over what? 3 squared. So what's the rule? Where does the exponent go if there's fraction? Goes to everything. So how do I write that out in nice terms like this? X over y to the a is what? Excellent. Why did I have to use x and y there? Because I need 2 different bases. Because if I used the same letter, I would just subtract those, wouldn't I? Nice job. Is everybody cool with that one? All right, now I want to show you an example. Again, do not write this down. Just think about it. Everybody just think. You are all aware that 2 over 3 squared is 4 over 9, yes? Okay. What would happen if I wrote this? Anticlimactic. Computer's frozen. X squared over y cubed to the 4th. Think about it. You don't need to write anything down. Take a moment. Think about it. Remembering what I said earlier about how all laws apply all the time. Sam? So what is it? Is everybody cool? Okay. Sweet. All right. Now, number 5 should be a super simple one, shouldn't it? What is 3 to the 0? 1. This is why. 3 cubed is what? Properly. No, properly. What does that mean? 3 times 3 times 3, which is 27, yes? 3 squared is what? 3 times 3, which is 9, yes? 3 to the 1 is what? 3, which is what? 3. What's the next logical exponent? 3, 2, 1, 0. Can I write something here? No, because there's nothing there to write. The base is multiplied 0 times. So the answer is, what math happened there? Divide by 3. So what math happened there? Did that just happen twice in math? So what happens now? What's 3 divided by 3? 1. That is why everything to the 0 is 1. Everybody cool with that? Now here's where it gets tricky. Every kid, and if you're a yeller outer in this class, I would bite my tongue to make sure you don't yell out the wrong answer. What is negative 3 to the 0? Negative 1. Why? Because Jake used his calculator. But why is it really? 3 to the 0 is 1, and the negative in front stays there. What then is this? 1. Because that negative is part of the base, and every base to the 0 is 1. So what's the rule? The rules I've been writing in blue. X to the 0 equals 1. Negative x to the 0 equals negative 1. And negative x to the 0 equals positive 1. Is everybody cool to there? That is where every single one of you should have gotten to in the 9th grade. Or if you were from another country, grade 4. Okay, right, Giovanna? About grade 4? Right? 5? Oh, grade 5. Brazil is so slow. Shocking. Rena, when did you do these? Grade 3? Ooh. Why are we so far behind in math? No, it's not because it's Asia. It's because other countries in the world don't believe in caring about your feelings more than they care about what you know.
Unless you're Finland, and you just all only care about feelings until grade 1.
Actually, Finland doesn't care about much of anything until grade 3. And then you know what they find out? Everybody's caught up by the end of grade 3.
Maybe we should start doing things like that.
We should.
Because if we should just start making them split.
Then maybe we wouldn't have teenagers that do things like kill little animals.
That's not when you either really smart
All right.
kids or kids that are having fun.
Number 6.
Can't be both.
2 different bases raised to the same exponent. Doesn't that look very similar to exponent law 4? Except instead of being x over y, it's x times y, right? So if I gave you 2 times 3 squared, what would that be? There's 2 ways to write it. It's 2 squared times 3 squared, and it's also 6 squared, right? Agreed? Yeah. Agreed? In grade 9, which one did your teacher stress? That one or that one, probably? They stressed the second one because we can do 2 times 3, can't we? And bed mass, right? Now, does this second one, does that work when I change the rules to be x, y squared? Can I do this one? Why? Because you don't know what x and y are. So then I got to remember it's this rule that we stick with. So it's x squared, y squared. Right? So how do I write it out nicely? xy to the a is xa, ya. Right? Do all previous laws apply?
Yes.
Yes. So don't write this down. What is this one? X cubed, y to the 4th, z to the 6th, squared. Just think about your answer. No, we can't stop. Oh, you said please stop. I thought you said can we stop? No, we can't.
Sam was just slapping his legs. He's really going.
Oh. What's the answer? No. X to the 6th, y to the 8th, z to the 12th. Is everybody cool to there? Okay, now listen to me. I'm not joking about this. The next thing we're going to do is actually a little complicated. You have to be good up to here. Is everybody good with exponent laws 1 through 6? Even when I mess around with them like this. You're all cool with that? Okay. Negative exponents. Negative what? 7 to the negative 3. What does that? Don't say anything for a moment. What does that mean? Do not tell me anything you are going to do to it. Tell me what it means. So Aiden's guess is it is negative 7 times negative 7 times... Shut up! Negative 7 times negative 7. Is that okay? Really? What's the base here? So what repeats? What has Aiden written? So is that right? Okay. Stop. So what's the next guess? The obvious answer is wrong. Okay, give it a shot. Yes, it does, but stop for a moment. All right. This is saying the base of 7 is going to multiply by itself negatively. Right? Is that possible? No. This makes no sense as repeated multiplication, does it? It makes no sense as repeated multiplication, does it? All right. So now I'm going to show you guys, and you're going to use your brains because you're super smart kids. On the previous page, we made a little chart, yes? Okay. We're going to make that same chart, but we're going to use 2 because 2 makes it easier. 2 cubed equals 8. Yes, we're skipping the repeated multiplication. Everyone's cool with that, right? 2 times 2 times 2 is 8? Okay. What's the next logical descending exponent? 2 to the 2, which would be 4. How did I get there? Divide by 2. Cool? What's the next logical descending exponent? 2 to the 1. What do I do to 4? Divide by 2. What's 4 divided by 2? Excellent. What's the next logical descending exponent? 0. Divide 2 by 2. 2 divided by 2 is 1. Everybody's cool with that. You already told me you were cool with that when we did exponent law 5, right? What is the next logical exponent? 2 to the negative 1. If it happens once in math, and we just made it happen 4 times, what happens here? Divide by 2. 1 divided by 2 is a half. Got it? What's the next logical exponent? Negative 2. What should I do to this? What's half divided by 2? A quarter. What's the next logical exponent? Which is a quarter divided by 2, which is 1/8. Now, use your brains. 2 to the positive 3 was 8. What's 2 to the negative 3? 1/8. 2 to the 2 was 4. What's 2 to the negative 2? 1/4. 2 to the 1 was 2. What's 2 to the negative 1? 1/2. Please notice the pattern. How is 8 really supposed to be written if we weren't lazy? 8/1, right? When I get a negative exponent, what happens to its positive counterpart? It reciprocates. So, what's the rule? X to the negative a is the same as 1/x to the positive a. Does everybody understand that?
Yeah, boy.
Now listen. Everything we've done has led us to 2 or 3 more discoveries, yes? So let's do the same thing here. If I have x to the negative a gets me 1/x to the positive a, what would this be? 1/x to the negative a. That's just x to the a, right? Because this negative isn't allowed, so we flip the fraction. Everybody cool with that? All right, now, do all exponent laws apply all the time?
Yes.
So what if I had this? X over y to the negative a. Sam? Y over x. And again, this would be so much cooler if my technology worked. Y over x to the positive a. Everybody understand that one? It's an A, Josh. The same way it's been all the way along. They've been A's. Is everybody cool? Everyone is good? Yes? All right, now, again, I don't want you to write this down. I just want you to think. Because there's only 7 rules here, yes? And they all make sense if you write them out, yes? So this can't be that difficult, can it? And yet, it gets difficult. Okay? Because you guys are so busy trying to write stuff down that you're not thinking. All right? So everybody stop for a moment. I'm going to do a couple of things over here. I just want you to think about it. What would x squared be if I divided it by y to the third? Jack?
Well, since they don't have the same base,
Exactly.
So it would be x to the 4 divided by 1 and 3.
Absolutely right. Because they have different bases. Good man. Sam? Yes. What would 2x squared over 2y cubed be? There's supposed to be a 3 there. Again, just think about it. Jack?
It would be x to the 4 over y to the 3.
Not
Oh,
quite.
It would be
2. 2 squared. X4
over 2 cubed y3.
No. So close. No brackets down there. 2y3. Now, what do you see here?
2.
Are they the same base?
Yep.
So can we do something with the exponents?
Yes.
What?
You can divide them
So it's 2 minus 1.
so it's
2 to the 1, which is just a 2, yes?
Yeah.
So this 2 will disappear. And one of those 2's will disappear. So my final answer would be 2x to the 4th over y cubed. Is everybody good? Okay. Which part? Yeah, you're going to get a lot of practice on. You guys did so well, actually, with this. You understood it so quickly that I jumped 2 days ahead. I didn't give you any practice on this stuff yet. This is like what I want to do Monday. So I've gone ahead because you did so well earlier. So if this one gives you trouble right now, you're absolutely fine. You're actually ahead of where I want you to be, if that's the first trouble you had. Is everyone cool? All right, now listen to me and listen to me closely. I am giving you no work tonight because you have a test tomorrow on something that should be relatively easy by now. 3 choices. Draw a triangle, choose one of the 3, apply it. Right? You have a review. You have all kinds of study stuff. I am going to tell you right now, the back of your test has SOHCAHTOA and Pythagoras and a triangle drawing on it. You don't even need to memorize it. Okay? Okay. There's some extra stuff on it too, but that doesn't apply to you guys. I'm going to remind you of that when I hand you the test tomorrow. I want you now to spend 11 minutes, or however long we actually have in class, getting your trig trigged. Okay? I want you to know it. There is no reason for not getting at least a B on the test tomorrow, considering A, how much practice you should have done, and B, the fact that if you draw a triangle, the test tells you how to do it. Right? You got to know 3 things. What's the hypotenuse? What's the adjacent? What's the opposite? Which are the 2 that change? Opposite and adjacent. Depending on what, Ethan? No. Where the angle you're working with is. What's the fancy name for the angle you are working with? Theta. Which is a Greek letter. Is everybody good? Sine, cos, tan. That's it. Okay? Everybody all right? Okay. I'm going to shut up. You guys had a heavy day, and you did very, very well. Tomorrow, the test is not an 80-minute test, but I'm giving you 80 minutes. If you get done, I'm going to assign you a page from your Outrageous Orchid book that you know how to do. Okay? It's exponent stuff, but it's not this level of exponent stuff. All right? That's what you're going to work on in class tomorrow, and then you're going to have the weekend off. If you take the whole period, then you're going to have to do that 1 page for weekend homework. Alright? If you really think you're 100% good with trig, you can go ahead in your Outrageous Orchid book and work on page 81 and 82. But I remind you, if you're going to choose to do that, and you finish your test early tomorrow, and you've got nothing to do, and you start jibber-jabbing with your neighbor, that is going to make me unhappy. Okay? Because there are kids in the class that will still be trying to write their test. Everybody good? So your choice now, study, ask questions of your neighbor, ask questions of me, or work on 81 and 82.